Welcome to our channel Autodrive. When we talk about the naval vessel funded under the FY 2026 budget, we're looking at what is expected to become the next evolution of large surface combatants in the United States Navy. This destroyer concept builds on decades of operational lessons from ships like the Arleigh Burke-class destroyer while preparing for an era defined by hypersonic missiles, long-range precision strike, space-enabled targeting, and autonomous warfare. The central idea behind this platform is not just incremental improvement, but architectural transformation, designing a ship with enough power, computing capacity, and physical space to support technologies that are still in development today. At the heart of this destroyer is an integrated power system, IPS. Traditional warships use separate mechanical systems for propulsion and electrical systems for onboard electronics. In contrast, this vessel generates large amounts of electrical power and distributes it across the entire ship through a unified grid. Gas turbines or advanced generators produce electricity, which then drives electric motors connected to the propeller shafts. This approach offers several advantages. First, it increases fuel efficiency because power can be optimized based on operational needs. Second, it provides enormous electrical headroom, critical for energy-intensive systems such as next-generation radar arrays, electronic warfare suites, and potentially directed energy weapons like high-energy lasers. The Navy's long-term strategy anticipates weapons that require megawatts of power, and designing that capacity into the hull from the start avoids costly retrofits later. The propulsion system is expected to deliver speeds exceeding 30 knots, allowing the destroyer to operate seamlessly with carrier strike groups and amphibious-ready groups. However, raw speed is not the only performance metric. Acoustic quieting measures, such as advanced shaft design, vibration isolation, and hull shaping, reduce underwater noise, making it harder for adversary submarines to detect the ship. Hydrodynamic optimization improves range and endurance, allowing extended deployments without frequent refueling. Operational range is likely to exceed several thousand nautical miles, supporting global presence missions. One of the defining elements of this destroyer is its vertical launch system, VLS. Unlike earlier configurations limited by cell size, this new design is expected to incorporate a larger or more flexible launch architecture capable of firing an expanded missile inventory. That includes advanced surface-to-air missiles for fleet defense, anti-ship missiles for sea control, land attack cruise missiles for deep strike, and possibly intermediate-range conventional prompt strike or hypersonic weapons. In layman's terms, this ship could engage aircraft, ballistic missiles, surface ships, and land targets from hundreds or even thousands of miles away. The flexibility to tailor missile loadouts per mission gives commanders strategic versatility. Radar and sensor systems represent a generational leap. The ship is expected to feature a next-generation active electronically scanned array (AESA) radar, building on systems like the AN/SPY-6. This radar uses thousands of small transmit-receive modules to steer beams electronically at near-instant speed. Compared to mechanically steered radars, AESA systems can track significantly more targets simultaneously, provide better discrimination between real threats and decoys, and maintain performance even if individual modules fail. The destroyer's combat system fuses radar, infrared sensors, electronic intelligence, satellite feeds, and data from aircraft into a single coherent operational picture. This concept, often called sensor fusion, means the ship's crew sees a unified battlefield map rather than disconnected data streams. Electronic warfare capability is equally critical. Modern threats rely heavily on radar seekers and data links. The destroyer is expected to carry advanced jamming systems capable of disrupting enemy targeting, along with decoy launchers that can mislead incoming missiles. Cyber resilience is built into the architecture as well. Segmented networks, hardened data pathways, and secure communications ensure the ship can operate even under electronic attack. Stealth considerations also shape the ship's design. The superstructure likely incorporates angular surfaces and enclosed masts to reduce radar cross-section. While a destroyer cannot be invisible, minimizing its signature complicates enemy targeting solutions. Infrared signature reduction techniques, such as exhaust cooling and heat dispersion, further reduce detectability. Combined with electronic countermeasures, these features enhance survivability in contested environments. The ship is designed with reinforced hull sections, improved compartmentalization, and automated damage control systems. Sensors can detect flooding, smoke, or structural damage instantly, triggering rapid response protocols. Fire suppression systems are modernized, and redundant power distribution ensures that a hit to one section does not cripple the entire vessel. These features reflect hard lessons learned from past naval incidents and emphasize the importance of keeping the ship operational even after sustaining damage. Automation plays a growing role in reducing crew workload. Advanced condition-based maintenance systems continuously monitor engines, generators, and combat systems. Instead of waiting for equipment to fail, the system predicts maintenance needs, improving reliability and reducing downtime. Crew size may be optimized compared to earlier destroyers, balancing manpower efficiency with the need for resilience and effective damage control. Living quarters are expected to incorporate ergonomic improvements and enhanced connectivity, supporting crew morale during long deployments. Another major differentiator is the ship's integration with unmanned systems. The destroyer is expected to act as a command node for unmanned surface vessels (USVs), unmanned underwater vehicles (UUVs), and unmanned aerial vehicles (UAVs). This distributed maritime operations model expands sensing and strike range without placing additional manned ships at risk. For example, drones launched from or coordinated by the destroyer could conduct reconnaissance hundreds of miles away, feeding real-time data back to the combat system. This networked approach transforms the ship from a standalone combatant into the center of a wider operational ecosystem. Computing infrastructure is also future-focused. Open architecture software design allows rapid updates and integration of new capabilities without rewriting the entire system. Modular hardware bays mean that future weapons, sensors, or communication tools can be installed during maintenance cycles. This adaptability is perhaps the vessel's strongest selling point. Naval ships often serve 30 to 40 years. Building and upgrade pathways ensures the destroyer remains relevant across multiple technological eras. Strategically, this FY2026 destroyer reflects a recognition that maritime competition is intensifying. Potential adversaries are investing heavily in anti-access and area denial systems designed to keep U.S. forces at distance. By combining long-range strike, robust missile defense, electronic warfare dominance, and power capacity for future energy weapons, this platform is designed to penetrate and operate within contested zones. It is as much a deterrent symbol as a combat tool. In practical terms, for viewers who may not follow defense budgets closely, think of this destroyer as a floating high-tech fortress and data center rolled into one. It can defend Allied fleets from missile attacks, strike targets far inland, coordinate drone networks, and serve as a visible projection of national power. Its unique selling points lie in its power generation capacity, modular missile flexibility, integrated digital architecture, and readiness for next-generation weapons. Instead of being optimized for a single mission, it's built as a multi-domain warfighting platform capable of evolving with emerging threats. That combination of adaptability, lethality, and survivability positions it as a cornerstone of the Navy's long-term fleet modernization strategy.